Alright, let's begin today's stream. We're gonna solve this question today, which is Indian Dictionary, a Leetcode hard question. Alright, it is locked. Great. We gotta solve it on Leetcode itself then. There is a foreign language which uses the Latin alphabet, but the order among letters is not A, B, C, Z as in English. Okay. You receive a list of non-empty strings of words from the dictionary with the words sorted lexicographically based on the rules of this new language. Non-empty strings of words from the dictionary with words are sorted lexicon. Alright. Derive the order of letters in this language. If the order is invalid, an empty string. And if there are multiple valid order of letters, return any of them. The string A is lexicographically smaller than a string B if either of the following is true, which is the first letter with the differ is smaller than A, smaller in A than in B. Okay. There is no index I such that AI is not equal to BI and here. Okay. ZO. HRN, HRF, ERENN, RFNN. All right. How does this work? From HRN, HRF, we know. N is less than F, right? Then HRF and ER means H is less than E. Then ER and ENN means R is less than N. RF, ENN and RFNN means E is less than R. One possible solution is HERNF. Alright, how does this work then? Let's see. Cool. Cool. Delete this page. Alright, let's see what to do here. HRN and HRF means basically N is smaller than F. N, then F, right? Then we have E and H. It's like H, and then comes E. We have ER and N. Right, R comes before N. That's the order till now. Then it comes R, F, and N. So it's like E comes before then R. So current order is R and N. This is what you have as of now. And N goes before F, so it becomes something like this. This is what my current order is. All right. Enough. Yeah. Now, how do we design this? All right, let's see. I have H first place. Then I have E, R, N, and F. Over here, what I get to know is N is less than F, right? So it's like this node. This becomes a node. Then comes the turn of then what? R is going over here. F, sorry, N is before F. Then I come to next one. H comes before E. It's like this. This is the in degree for E. Okay. Next comes E R N. This becomes in degree of this. Then comes what? ENN or FNN. Something like this. Cool. So what do we do? It's very simple. Is it simple or not? Now, first of all, first letter is minimum in degree. Alright, that's how you do it. That's the kind of graph you get to see. First letter is minimum in degree. That becomes my first letter. Yeah, so it's like this is my first letter over here. What about the other two? Other four letters, how do you identify it? It's like you take letters in pair, take words in pairs. Like I first take this one. This one I take along with, oh fuck, along with this one, right? And I keep on traversing until I find a distinguished letter. As soon as we find a distinguished letter, we add it as a node in our dictionary, right? Yeah. So after that, what we do is, since we have a graph, we have a directed graph, right? It's like the directed graph with in degrees. What if we do a topological sort on this? Alright, let's do something. Turn here and F here. This work. Ideally, it shouldn't work, right? It will fail over here also. It's like HER and F is the sequence you have over here. It is saying so. One possible solution is Hanbach. What are all the possible solutions? How do we get that? Okay. got it. How do you do it? And I got a directed graph with in degrees. What next? So, how do we do this? That's interesting. Okay, we got this. Then we can create any adjacency list using this, right? Yeah. Okay, what if I found a cycle over here? Like, what if it was like this? What would happen in that case? If I had a cycle, I don't have anything to start with at the first place, right? At that point, it would be just like, okay, there's no valid ordering. So if a cycle detected, since no specific order can be detected, right? Okay, let's so the steps will be something like this. Words and edges. Then what you do? Since we have in degree over here, what if we do a topological sort? Do a topological sort. If cycle is detected, return empty string. Else return the sorted order. So these are the three steps that we need to do, I guess. Let's just do one thing and paste it over here. Cool. These will be the three steps most probably that would lead us to our result. So now the question is, how do you code it out? Right? Coding it out is the difficult part, I guess, over here. Uh, First of all, the edges will be for every single letter present in these strings, right? So it's like Alright, so it's like, since we need this kind of adjacency list, let's do one thing. Let's create a hash map of string, or maybe character, to a set of character. This will be my adjacency list. Right, next what we need is right, quick solution. This will initialize my hash map. For now, let's do one thing. For every single word, word to array adjacent dot adjacent new asset. Initialize the adjacency list with raw data at first. Next, what you need is you need to traverse every single word, right? For int I 0, word 1 is words of I, word 2 is words of I plus 1. What you need is, first of all, okay, so for example, these are the two words over here, different lengths, href and er, right? We need to find out the minimum length because we only need to traverse the number of minimum characters over here. So int I got the minimum length. Now what if it was something like href and hr है हमारे पास, and hr comes afterwards, that case will return an empty string definitely. So it's like, basically, if all right, correct. So for int j plus plus adjacent dot get word 1 dot char at j dot add get char at j, and you just break it from here because this is the breakpoint for the current word matching. It's like you have ENN and RFNN. Even the first letter gives us the difference between both these two words, so we'll break it over here, right? Next thing is, we have created the adjacency list. All right, we need to maintain a visited array, right? Visited wala thing. So it will be like hash map of This is the new hash map character to boolean called visited. Uh, private. H. How do you code this ahead, man? It's like, wait a second. Do I need to do topological sort over here? I don't need to topological sort now. Do a DFS simply. Suppose predicted return empty string, else return the order. Great, you have a visited over here, and for every single character, which is what? Just dot reset at DFS of return dark. Right now, DFS में I need to pass visit also. Dot contains key. All right. So basically, what we are doing here is very simple. It's like we are maintaining the current path visited. It's like what all nodes we have visited in the current path. That's what we are doing right now. All right. What next? We do. Should I put mark it as false? Then afterwards, once you have finished visiting this path, you also need to maintain the order in which you are visiting, right? So it will be like, all right. Let's do this now. Okay, so what will this do basically for this one is it will start from H. Where is my this? Alright, it will start from H. It will go to next node E, then R, then N, then F. Should ideally do this, right? Alright, let me for char ch. Alright, will this work? TFS next visited. Alright, what happened over here? Cool. And pass raise over here. Index 2 out of bounds for length 2. That's interesting. For length 5. Okay, where did it happen? And in the Java 46. Alright, this would work. These two. Okay, why is it getting it in backwards order? Alright, since we're doing a DFS, what it's doing is it's adding the last character first. So it's like, where is that thing, man? Right, so it's working in the backwards order basically. It's like you start with H, you check if it is visited. Nope, it is not. You mark it as true in current path. Get next. Next is E. You go on DFS, you then go on R, then go on N, then go on F. Then you have nothing in front of it, right? Visited dot put, you mark it as false in current path, and then you add it in raise, which is F. Then you come back, received false, adds in and all. Got it. So it's like collection dot first raise corrections होता है ना? I guess it is collections dot reverse raise, and this should work. I think it worked. Nope, it did not. Here I put KW, KJWTR, WRT, KJWRT. Alright, over here WRT should come before this. Am I not handling this case? It's running for this amount of time, which is WRT, WRT. Didn't find anything distinguished, and it went ahead. So this is the case like if word1 dot length is greater than word2 dot length, and word1 dot substring 0 to min length dot equals. Yeah, it worked. Any coding advice for someone who just started DSA? I am also running DSA as of now. Let's just keep doing the DSA sheets of neat code and striver, nothing else. That's all I got. Alright, let's see this question again. I just replied, bro. just enter new hash map. Okay, hash map we create we do take adjacent words, create directed edges, yep, create adjacent list using these edges, yep, do if cycle is detected, return empty string, else return the final order. Cool. Yeah, makes sense. Basically this means a tag, yep. What is this case again? Okay, you don't need to write this out. And yeah, cool. Let's solve one more maybe. And then that'll be it. Actually, a second. I got. Do we have any update on these issues? Okay, let's see what's it. For this, I have to make changes in Cali front end. At those changes, but I don't have right access for that. Permission to run this Cali front end not get denied. Like, the request will returned error 403. Okay, what is the changes that Lakshya made? Let's see. Alright. I did not run backend as I needed multiple API keys for that. So I created a metadata. Just take time out to mimic API. Alright. Why didn't he have access for that? Let's see. Oh, of course he won't have the right access to that. And cool. I think this would work fine over there on Cali front end. Let's see what he did. Did he fork or not? I think he forked. Yeah, alright, he got a fork, the repo, and then he can do that. Cool. What else do we have? Let me raise an issue over here now. We don't need to actually. What is the status of DB? Do we have no users? Let's see what we have over here in users. All right, we do have some new users. That's great. Cool. I think We can move it to here. I'll have to eventually move my DB over here, most probably, because I1 DB is not that reliable to me. Cool. Waiting request. Have anyone started this? Nope, nobody has started this. Alright, what do we need for this is, let's see, we need a cron to run every 30 minutes or so. What it will do is, it will just notify about the upcoming meetings. How does it do that? Alright, how do we, where is it? Let's see, meetings. Okay, what can we do if the accepted meeting is true, accepted flag is true, and responded is true? What we can do is basically we can run a cron job over here, and that cron will run every 30 minutes, and it will send emails to these users. That's an easy task actually. That cron can run over a lambda or something like that, and yeah, it's pretty easy task. Let me edit this. Oh man. Yeah, this can be an approach that can be used. Do we need anything? Nope. Cool. I think that's pretty good of a loader actually. He has implemented the loader, he has implemented the create meeting thing. That's good. He just needs to got it. What do we have in notifications? Is it not syncing? Alright, it should sync today at 11. Cool. Let's do one thing then. Let's solve this question. You set the timer, restart it. Cool. Your climb staircase, it takes 10 steps to reach the top. Each time you can either climb 1 or 2 steps, or it's a Fibonacci kind of thing. You can just take 1 or 2 steps. And how many distinct ways can you climb to the top? That's kind of a recursive question. DP. I do remember this solution actually. It's been It's, it's like basically if you have two steps, there are two ways to climb. If there are up to three steps, there are three ways to climb. So it's like if n is less than three, you return n. Otherwise, previous one is 3 plus 2. Right. It is basically the previous number of steps. And now what we do is I to n. Previous 2. This would solve the question actually. It is basically a Fibonacci sequence. You keep on adding previous two steps, and that's how you get your final answer. It was just a dumb question to solve actually. Anyways, alright, that's it for today. I gotta go do some work. So yeah, thanks for watching. Have a good night ahead. Cool, bye bye.